Chapter 5 review. Yes? You need one? Okay, let me see if I got one in here. Let's see here. Tell you what I'm going to do. When I get through writing on this one, I'm going to give you this one. Okay? It's got the answers with it. Lena makes home deliveries of groceries for a supermarket. Her only stops after she leaves the supermarket are at traffic lights and the homes where she makes the deliveries. The graph shows her distance from the store on her first trip for the day. What is the greatest possible number of stops made at traffic lights? It's in that top tray on the bottom. So, what do we think? How many times does she stop? 4. But one of those is longer than the others. Why do you think? She had to make a delivery. Okay? So, the other ones are the traffic lights, and how many are there? 3. Okay. Number 2, find the domain and the range of the relation. The domain would be this list of numbers, but you don't have to write them down repeatedly. So you would write 30, 49, and 62. The range is 24 and 48.
You want to put on the least of grades?
Yes, normally they're listed smallest to largest. I would not count it wrong if you didn't do it that way, but that is the way it's normally done. Number 3 says evaluate. X is -1, so you're going to take that -1 and place it in place of the variable. So it's -2 times -1 minus 7. -2 times -1 is 2. 2 minus 7 is -5. Number 4, evaluate. You're going to place the -3 in place of x. So it's -1/2 times -3. First, it's going to turn it into a positive, and half of -3 is 1.5.
Is that the same as 3/2?
Yes, it's the same as 3/2. Number 5, a taxi company charges passengers $1 for a ride, no matter how long the ride is, and an additional 35 cents per mile. The rule C equals 0.35 m plus 1 describes the relationship. What is the charge for a 1 mile ride? You're going to put a 1 in place of m. 35 cents times 1 plus $1 is $1.35. A 2.7 mile ride, you're going to put 2.7 in place of m. 35 cents times 2.7 plus $1. So let's see what that is. $1.95 is going to be what they charge you. Number 6 asks you to graph the equation. So go to y equals. Put that in your y equals 3x minus 2. You can go to the table and plot some points and draw the line, or you can press the graph button. Where does this graph look like it crosses the y-axis? See if you can tell. -2. Go to your table. When x is 0, y is -2. Okay? Can we do this tomorrow? Your test will be multiple choice. Can you put that in and pick the right picture? Yes? Okay, let's go to the next one. Go to y equals.
When we do that,
Mhm.
will you just want us to just put the x and y coordinate, or you want us to make a graph?
You're just going to choose the right graph. It's going to be multiple choice.
Oh,
Okay. Number 7, absolute value of x minus 2. How do you get absolute value bars inside y equals? Do y'all know how to do that? How do you get absolute value? Second 0 is where you're going to go. Second 0 brings you to the catalog, and the first option in the catalog are the absolute value bars. And inside there you place x, and then you put minus 2, and then you can go to the table. But what is probably more helpful is to go to the graph. Okay? Second 0, then press enter, and then put x. Sometimes it doesn't put the bar, sometimes it says ABX. So X is the button beside the green button. Yeah, close parentheses. Minus 2. Graph. Okay. Where does this V look like it crosses the y-axis? -2. Wonder why. Wonder why both of those cross the y-axis at -2. Do you think it says that in the equation? You see where it says -2? Okay, go to the next one. Clear this out. Negative absolute value. So you put a negative sign, and then you put your absolute value bars in. And what do you put inside the absolute value bars? 3x. And then outside the absolute value bars, you put +1. I wonder what that negative is going to cause this thing to do. What do y'all think? You got negative, right? Press the negative button. The second 0. Enter. And then put 3x. And close parentheses. +1. And graph. What's the negative cause to happen?
Causes it to go like that.
It goes upside down. That's what a negative will do out there. It causes it to go upside down. Where does this cross the y-axis? 1. Why? Well, because you told it to. That's what that job of that number is right there. It tells it where to cross the y-axis.
Right, so I have a question.
Uh-huh.
So whenever it says like +1, that's like the y, where it's going to cross the y-axis?
Mm-hmm.
Okay.
Next page. Write a function rule for each table. What do you think about number 9?
X times x equals 2.
Okay, so f of x is equal to x times 2. Okay, write it like that. What about number 10?
X plus 2.
Okay. 11 says the length of a field in yards is a function of the length in feet. N is the number of feet. Write a function rule for this situation. F of n, which is yards, is equal to, what are we going to do to the number of feet to turn it into yards? Let's think about some numbers and you tell me what you would do. What if I told you I had 12 feet? What would you do to turn it into yards? Divided by 3. What if I told you I had 15 feet? So what do you need to do to n? Divided by 3. So it equals n divided by 3. Crystal earns $5 per hour mowing lawns. Write a rule to describe how much money M is earned is a function of the number of hours spent mowing lawns. So money equals 5H. How much does she earn if she works 2 hours and 45 minutes? Well, how much does she work if she works 2 hours? That's easy. The 2 hour part's simple. $5 an hour, 2 hours. How much money is that? That's $10. She's gonna work. She's gonna earn a little bit more than $10. Is she gonna earn $15? How long would she have to work to earn $15? Another hour. She didn't quite work that long. How much of an hour does she work? 45 minutes. What part of an hour is that? It's in there too. How much does she work? So we're going to multiply 5 times 2 and 45 out of how many? What do y'all think? 60. Why 45 out of 60?
Because it's the 45 minutes out of the 60.
Yeah, don't put 2.45. So let's go to our calculator. What is 45 out of 60 as a decimal? Because you like to use decimals better than you do fractions. What do you get? 0.75. So you could really multiply 5 times 2.75. And I get $13.75. Number 13, find the constant of variation K for the direct variation. That means you need to solve for Y. How do you get Y by itself? What do you do here to solve for Y? Minus 5x. So it says Y equals negative 5x plus 0, but I don't have to write that down. Now, is that a direct variation? How do you know whether it's a direct variation or not when it's in this form? What do you check for?
If it crosses through 0.
If it crosses through 0, 0. Now, all day long, the number added to the end is where it crosses the y-axis, right? Is there a number added to the end of this one? Is it? No. So it's going to cross at 0. So if there's nothing added to the end, or if there's a 0 added to the end, then it is a direct variation. Now, the K value is the number in front of X, negative 5. The total cost of gasoline varies directly with the number of gallons purchased. Gas costs $1.97. Write a direct variation model for the total cost of G gallons of gasoline. So C equals $1.97 times G. 15. Use inductive reasoning to describe the pattern. Then find the next two numbers in the pattern. What's going on in 15? What do you think, Lucas? Plus 3. Add 3. What's going to be the next number? 2. And then the following one?
5.
Good. What's going on in number 16? Think?
It's x times negative 2.
They're multiplying by negative 2. How do you know they're multiplying by negative?
Because whenever you multiply 4 times negative 2, you get negative 8, and negative 8 negative 2 is 16. And then
So when the signs change, negative, positive, that's a clue that you're multiplying by negative. And then you just have to figure out what number you're multiplying by. So we are multiplying by negative 2. What's the next number going to be?
64.
And the following?
Negative 128.
Good. Find the common difference. The common difference in an arithmetic sequence is,
add or subtract.
they want you to say always, sometimes, or never. That's what I'm thinking they're asking for here. Hang on a second. What number are we on again?
17.
Yeah. Is the common difference always a positive number? No. Sometimes. Sometimes you're adding, sometimes you're subtracting. Okay, 18. Model the function rule with this and give a table of values. So here we go. We're going to go to y equals. Everybody get their calculator ready. Go to y equals. Put in negative 2x plus 0. You don't have to put the plus 0, but since they put it in there, we will. There's your picture, but let's go to the table. I think it's going to be more helpful. What's the x value? When x is negative 1, what's the y value?
Negative 2.
It's what? 2. When x is 0, what's y?
0.
When x is 1, what's y?
Negative 2.
Okay, then you're going to plot these points on your graph. Negative 1, 2, 0, 0, 1, negative 2. Okay. It looks like the calculator. We good? $19. Elaine is in the business of repairing home computers. See, she charges $45 for each visit and $40 per hour for her labor. Cost for a home visit is given by this function. They want us to graph that. Okay, so we're going to go to y equals and we're going to put this back in our calculator. 45 plus 40x. Put that in. How much are you going to have to pay her just for coming to your house? $45. Now, I realize in real life, if she's not going to do anything, she's probably not going to come to your house, right? So you're probably not going to have to just pay this woman $45. But for the algebra side of it, which we're working on, when x is 0, our value is going to be 45. So here we go. I think the best thing we can do is go to the table. And when x is 0, what's the price going to be?
45.
When it's 1 hour. When it's 2 hours. When it's 3 hours. How much do those prices go up each hour? $40. And that's the number that we're multiplying by x in the problem. Now, how are we going to graph this? I mean, we're not going to start out going 1, 2, 3, 4, 5 on both axes.
It's going up $45.
It's going up $40. It starts at 45 and it's going up $40 every time. For every extra hour, you add $40. Now, you're going to start, and on the x-axis, I want y'all to put time so you know what you're talking about. And we do use 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. We do that on the time. But on the other one, we don't. And we don't start at 45. Don't put 45 down there at the bottom. We need to decide what we want to count by. What's the smallest number we're going to have to do something with? 45? And the largest one is what? 165. So I'm going to have to count by 5s or 10s or something like that. If I count by 5s, kind of think about it, take your finger and go up. If you count by 5s, and you need to get to 165, you need about 15 to 18 lines. Do you have that many? No. Okay. Well, let's think about counting by 10s. If we count by 10s, we're going to need 16 or 17. Are there 16 or 17? No. Okay. Well, how about if we count by 20s? If we count by 20s and we need to get to 160, we're going to need 8. Would that work? Would that be reasonable? Do y'all want to count by 20s? Or do y'all want to count by 25s? 20s? Okay. Let's count by 20s. So the first line is 20 right here. The bottom is 0. This is 20. This is 40. Okay. This is 60, 80, 100, 120, 140, 160, 180. I know it's really hard for you to read that, but we're counting by 20, so you get yours designed like that. Yeah, I stopped at 180. You can keep going if you wanted to. Always try to go a little bit past your highest number. Now, when the time is 0, where do you put your dot? We're at 45. So 0 is 45. So just a little bit above 40. Okay? After 1 hour, where do you put your dot?
85.
In 2 hours? In 3 hours? Okay. Could you predict the cost for 7 hours if I asked you to? What would you do? What would you do if I asked you to predict the cost for 7 hours? You could add 44 more times. That's building onto the table. Could you use 7 in the equation? Could you multiply 7 times 40 and add 45 and get the same number? Yes. Could you extend the table and the graph? Yes. Okay. For the data in the table, tell whether y varies directly with x. How do you know that? What do we do for number 20 to decide whether it's yes or no? You need to make ratios in the form y over x. So the first one is 4.9 over negative 1, 4 over 0, 3.1 over 1, and 2.2 over 2. Now, do these all have the same value? No. So this is not a direct variation. 21, is it a direct variation? Solve for y. So what do you do to solve for y? Okay. Now you really can't subtract 3x from anything. It's just going to say negative 3x plus 5. Where's this one going to cross the y-axis? Look at that equation. Tell me from the equation where this thing's going to cross the y-axis. 5. So is it a direct variation? It has to cross a 0 to be a direct variation. Is it going to do that? No. Because that plus 5 is on there, this is not a direct variation. 22. Find the range. You're going to put this in your calculator. Get your calculator out and go to y equals. Enter the function 3x minus 4 and go to the table. You don't need every number from the table. You need a specific set. You need to know the y value when x is negative 4. What is it? When it's negative 3.
Negative 13.
When it's negative 1.
Negative 7.
And when it's positive 1.
Negative 1.
That is your range. Okay? Can we find that from the table? All right. 23, sketch a graph of the speed of a city bus on the daily route. Label the section. The bus pulls away from a stop and increases its speed. Let's see, I bet I have this. I'm going to show you what they have. The bus pulls away and increases its speed. Read me part B. I can't show you both things at once. What does part B say on your paper? It does what? It has a constant speed between stops. So we're looking at speed and time. We're not looking at distance. If you looked at distance, your line would grow away. We're looking at how fast you're going. You take off and you start going faster, and then you get a constant speed. That's why it's flat. And then what's going to happen next? What does part C say?
Bus will stop.
Stops. When it stops, what happens to the speed?
It
Goes down. If you were doing distance, it'd be a flat line, but we're not doing distance, we're doing speed, so you gotta go all the way back to 0. What does part D say?
Bus increase speed after stop.
So then it takes back off again, okay? So this is a city bus and it's gonna make stops. Its speed's gonna do this. Its distance won't. Its distance will keep going and have some flat spots in it and some straight, some linear spots. Be sure you know what you're talking about when you're talking about distance or speed.